Good morning, everyone. I'm Narmatha, Assistant Professor, Department of Cybersecurity, working in Dr. S.N.S. Rajlakshmi College of Arts and Science. In today's lecture, we are going to see about case study of Windows 7 operating system. Let's see. Windows 7. So it is a 32 or 64-bit primitive multitasking operating system for Intel microprocessors. Key goals for the systems are portability, security, multiprocessor support, extensibility in international support, compatibility with MS-DOS and MS Windows applications. It uses a microkernel architecture and available in 6 client versions and available in 3 server versions. Windows 7 architecture. So it is a layered system of module, predictor mode, hardware abstraction layer, kernel, executive. So these are all the layers are presented. User mode, collection of subsystems, environmental subsystems emulate different operating systems, and production subsystems provide security functions. So Windows 7 architecture is represented by using this picture. We have um, different OS applications, Windows 32, 61, and other subsystems are presented in user mode. And in the executive mode or kernel mode, inside that we have input output managers, object manager, plug and play manager, process manager, and Windows manager, graphic device drivers, kernels, hardware abstraction layer. So these are all the layers are presented, and that is directly connected with hardware. System components. First one, kernel. Foundations for the executive and the subsystems never paged out of memory. Execution is never preempted. Four main responsibilities of kernel is thread scheduling, interrupt and execution handling, low-level process synchronization, recovery after a power failure. Kernel is object-oriented, uses two sets of objects, dispatch objects and control objects. Process and threads. The process has a virtual memory address space, information, and an affinity for one or more processor. Threads are the unit of execution scheduled by the kernel's dispatcher. Each thread has its own state, including a priority, process affinity, and accounting information. A thread can be one of 6 states: ready, standby, running, waiting, transition, and terminated. Windows 7 interrupt request levels. So we have interrupt levels 31, 30, 29, 28, 27, 3 to 26, 2, 1, 0. So these are all the numbers. It represents different types of interrupts. So that is represented in this table. Trap handling. The kernel provides trap handling when exception and interrupts are generated by hardware or software. Exception that cannot be handled by the trap handler are handled by the kernel's exception dispatcher. The interrupt dispatcher in the kernel handles interrupts by calling either an interrupt service routine or an internal kernel routine. Executive Object Manager. Windows 7 uses object for all its services and entities. The Object Manager supervises the use of all the objects, generates an object handle, checks security, keeps track of which processes are using each object. Objects are manipulated by a standard set of methods, namely create, open, close, delete, query name, parse, and security. Naming objects, the Windows 7 executive allows almost any object to be given a name, which may be either permanent or temporary. Object name are structure like file path names in MS-DOS and Unix. It implements a symbolic link object, symbolic links in Unix that allow multiple nicknames, aliases to refer the same file. Process gets an object handle by creating object by opening an existing one, by receiving a duplicate handle from another process, or by inheriting a handle from a parent process. The design of a VM virtual memory manager assumes that the underlying hardware supports virtual to physical mapping, a paging mechanism. The VM manager in Windows 7 uses a page-based management scheme with a page size of 4 KB. Windows 7 VM manager uses two-step process to allocate memory. First step preserves a portion of the processor disk space. Second one commits the allocation by the assigning space in the system's paging file. So the layout of virtual memory is given here. So page directories, page tables, and 4KB pages represented in this picture. Virtual Memory Manager. The virtual address translation in Windows 7 uses several data structures, page directory, page table entities, and 4KB page frames. 10-bit integer 10-bit integer can represent all the values from 0 to 1000 to 20 in the table, and translating address pointer to a Y address in physical memory. A page can be one of a 6 states: valid, zeroed, free, standby, modified, and valid. So this is the representation of virtual to physical address translation. So that this picture, it shows the for the virtual to physical address translation. So from this lecture, you can understand about a Windows 7 operating system, how the kernel works, and how we are working with the virtual memory concepts by using this Windows 7. Thank you.